Hey team, it's Mr. Z, and today we're going to go ahead and look at how to create new zeros of functions. Let's go ahead and jump on in. Okay, this section is all about dilating a function. We're going to create something of a degree 3. So this is new. We're going to start with a linear function f of x, and you can see f of x is drawn out. This is a linear function because the degree is 1. So what we're going to do, this equation is y is equal to 1 over 1 x minus 1. I know from slope-intercept form that it's going to have a y-intercept of 0, negative 1. I also know that it's going to be rise over run. So it's going to start at 0, negative 1. And then it's going to go up 1 over 1, up 1 over 1, up 1 over 1, so on and so forth. Okay, so we're going to dilate the function by a factor of x plus 3. Remember, dilate is essentially mean we're going to just be multiplying. So we're going to basically be taking x plus 3 and multiplying it by f of x. Our goal is to sketch the graph, and then we have to write the equation. So notice I have a 0 already. The 0 is when it's at the x-axis. F of x is equal to 0 when. So remember, the y is f of x. So here at the x-axis, f of x is equal to 0. I plug that into my above equation, and then I solve by adding 1 to both sides. Notice my x value is 1. My output, my y, was 0. And that's how I get to 0. 1 comma 0. That's how you find the x-intercept. You substitute 0 in for y. So let's go ahead and multiply by x plus 3. So we're going to do the same thing as last time, except for we're going to be also multiplying by adding 3. So let's start here at 0. So at 0, when x is 0, it's equal to negative 1. So let me go ahead and draw out my x and my f of x. When it's 0, it's negative 1. When it's 1, it's 0. I'm going to multiply the f of x by, in this factor, x plus 3. And then this is going to create my m of x, what I want. So what was x? 0 plus 3 is going to be 3. Negative 1 times 3 is negative 3. So the new output for 0 will be negative 3. Okay, let me do it again for the 0. Notice 1 plus 3 is going to be 4. 4 times 0 is 0. So the coordinate would be, here this was 0, negative 3, the x, and then this new y. In same fashion, this would be 1 comma 0. Notice how it didn't change? So this next point is here as well. Let me keep on going. Let me go ahead and try 2. 2, well, what was the output when it's 2? Looks like 1. Well, let me go ahead and take 2 plus 3, which is going to be 5. 1 times 5 is 5. So this next point is going to be at 4.25. 2, 4, 5. Okay, let me go ahead and go with -1. So, -1. What is -1? Well, -1's right here. So it's going to be at -1. Or no, -2, my bad. You can also plug this in to get the f of x value. Here, you can plug in -1, and it's going to be equal to -1 minus 1, which is -2. So I'm going to go ahead and multiply it by -1 plus 3, which is just 2. -2 times 2 is -4. So the new point, instead of -1 comma -2, it's going to be -1 comma -4. I'm going to go ahead and graph this guy, -1 comma 4, 2, 4. And you can see that this is starting to form a quadratic. So the idea here is the inputs stay the same, but since we are dilating it, we need to multiply the output, the f of x, by whatever we're dilating by. So what would this new equation look like? Well, m of x is equal to x plus 3 times f of x. Well, what is f of x equal to? X plus 3 times x minus 1. Okay. So, now my graph, the only thing you can know from this is a couple of things. Because it's factored form, I know that I'm going to have a 0 at -3 comma 0 and 1 comma 0. So when I'm looking at my graph, my sketch could technically be a little bit better